This is number 30 in chapter 16. It's basically a two-part question. There's part A and part B. Both are looking at calculation of a pH based upon the following conditions. So for part A, we have a solution that's 0.195 molar in acetic acid. We also have 1.25 molar potassium acetate, right? And so Tro doesn't like to write the charges, but those are our charges. So what we have here is a parent and a conjugate, and so as a result we have a buffer. Now the question is asking us to use a nice table, so we're going to use a nice table to solve for what the pH actually is. Now the first thing to do is to write the buffer in terms of the parent. So that is our parent. And that's forming our conjugate and H3O+. So we need to have a Ka, and so we have to realize that we have to find that Ka in the table back in the prior chapter of acids and bases, and the Ka for acetic acid is 1.8 times 10 to the negative fifth, and so we get that from a table. Now that we know the equilibrium, we can simply write our ice table for the major players of our equilibrium constant. Remember, our Ka is going to equal our products over our reactants. And so we have an initial, a change, and an equilibrium data set. We are beginning with 0.195 molar for our acetic acid, 0.125 molar for our acetate, and we aren't beginning with any H3O+ to begin with. That tells us our change. And so those are our three equilibrium concentrations with regards to X. We're going to do just like we've done before. We're going to assume that that X is negligible compared to these initial concentrations, and so our Ka, which is 1.8, is going to be equal to our acetate, which is 0.125 times X over 0.195. So now we can solve for X, which is equal to our H3O+ concentration, and that is equal to 2.8 times 10 to the negative fifth. So that's our concentration of H3O+, and so in order to answer the question and get the pH, we then need to take the negative logarithm of that value. So our pH is the negative log of our H3O+, or the negative log of our 2.8 times 10 to the negative fifth And so our pH is equal to 4.55. So that's part A for number 30. Again, it's just like what we've done in chapter 15, as far as looking at acids and bases and Kas and Kbs respectively. Because here we have two initial concentrations of our parent and our conjugate, which constitute a buffer. Part B is fairly much the same. Part B looks at, again, we're still trying to figure out the pH, and we're still going to use an ice table, but now we have 0.255 molar methylamine and 0.135 molar the methyl ammonium salt of methylamine. So here we have the similar situation. We have a buffer, we have a parent and a conjugate. Our methylamine is the parent base. Our ammonium ion, or that positive nitrogen, is our conjugate acid. And so we have a buffer here. So we just want to determine the pH. We again are going to write our equilibrium according to the parent. And so that is our equilibrium reaction. We can now generate an ice table, right? Because our Kb is going to be equal to again our products over our reactants. And from that we can generate our ice table. And so for our initial concentrations, we have the 0.255 for our methylamine, 0.135 for our ammonium or conjugate acid form, and then 0 for our hydroxide. And so those are our concentrations with regards to X, and just like we did with part A, we're going to say that X is 0 relative to those initial concentrations. We're going to have to look up that Kb, which we get from a table. So that's where that value comes from. The 4.4 times 10 to the -4th comes from a table. And we can plug in the other equilibrium concentrations. And we can solve for X, right? And X, remember, is going to be our hydroxide concentration. And X is equal to 8.311 times 10 to the -4th molar. So that's our hydroxide. Right, from our hydroxide we can get the POH, which is a negative logarithm of that value. And then from there we can get our pH once we subtract from 14, which gives us a pH of 10.92. So again, we can use the ice table to solve for buffer questions as far as getting their pH. We can also use the Henderson-Hasselbalch. The number 30 is showing you how to use the ice table with regards to this type of calculation.